Hey guys, I'm Cyborg Cheap, and welcome to the Weekend Post. In this episode, we're going to be building this right here. This is a power supply that I got from someone at school. He said he didn't want it anymore. He offered to give it to me, and I gladly took it. And today, we are going to build it. Now, you'll notice here, you see how it says Elecno there? Let me just bring that up closer so you can see. See how it says Elecno right there? Elecno, they're the same guys that make the snap circuits. So, similarities or something? I'm not sure. But, let's get into this thing. Alright, so, opening up the package. There we go. Okay, now, inside box, we have what might look to be solder. Now, I already have solder, so might be redundant, but I'm not sure. This might actually be jumper wire that we'll have to straighten out. Now, I have the instruction manual, or assembly manual, should I say. Instruction manuals are complete garbage. It's actually sort of made like a book, if you notice, because it has the, oh my goodness. Because you see right here, it's got the staples. Let's see what else we got in here. A whole bunch of electronics. Potentiometers, transistors, resistors, diodes. We have the main PCB. We have the main power transformer. Whoa, that doesn't look good. But anyways, and we have a power cord, and it has the two bare copper wires. You can see right there, maybe. Yep. And yeah, okay, so that's everything that you get in the box. So I was thinking that these two suckers right here will be your power input, and then there will be all sorts of DC outputs here, obviously through all sorts of taps. So let me take a minute, take a look at this thing, and then we'll get started soldering. Now this is intended to be a soldering practice kit. Although it serves to be useful as a power supply, it's definitely worth having too as a to get some practice on soldering. So I'm pretty good at soldering, but this will definitely be worth it. Alright, so looking at this bag here, I think I've shown you this before, but we have some passive components. All sorts of resistors and capacitors. This looks to be a transistor, although it could be a voltage regulator. You see right there, that little component. Now this I know for sure is a transistor. Voltage regulators would generally be in this package, the TO220. But usually transistors are in this package right here. However, there are transistors with this package, but I highly doubt that that's a transistor. Also, looking in the assembly manual here, you see this outputs AC voltage and DC voltage. DC goes from 0 to 15 volts, so it's completely variable, right through this potentiometer here that you can kind of twist to adjust the voltage. It goes, it has a maximum output of 2.5 amps, 2.5 milliamps, and the AC has a maximum voltage of 0.5 amps, or rather 500 milliamps. So I guess let's start soldering. I'll move the camera back onto the tripod. Oh, before I do that, let's open up this sucker right here. Got some structural components here. We have a heatsink. Now this will go onto the transistor, like so. Right here, this is a slide switch for turning on the power supply. This is what looks to be heat shrink tube, so I'll have to go and get a barbecue lighter for that. Some nuts and bolts, and a C-clamp for the mains wire. So let's adjust some camera angles. I might consider, although it won't fit, 10K 512M, maybe not. However, I have another potentiometer that I'll go and grab, and we'll see if it works. Well, maybe not, but anyways, let's get to work. Alright, as a first step, I started modifying the transformer. To start off, I split the two ends of the mains cord. And then I pulled them apart. After that, I stripped the two ends. And after stripping the two ends, I twisted the wires together. Then I sized the heat shrink. After doing that, I looked at the power cord and noticed something awkward about it. It's a two-prong cord, however, one of the prongs is slightly bigger than the other, indicating that there is a polarity here that has to be met here. However, there is no such polarity mentioned in the book, so I'm just going to solder them on at random. So first, I tin the two wires. After that, I soldered the two wires onto the transformer wires. And then finally, I shrunk the heat shrink down onto the to the solder joints to protect the connections and prevent shorts. After doing that, I secured the transformer down with two screws. However, on one side, I used a C-clamp to hold the wires on the primary side down. This will also act as a strain relief to make sure the wires don't get tugged. After that, I started working on the secondary wires. I cut them and stripped the ends off of them. I also made sure that I cut them so that there would be enough length to have extra. After that, I soldered the cut end onto the board. And cut the excess wires off. After soldering in two of the transformer wires, I soldered in the two excess wires, so that I could get an AC output as described in the manual. It is also worth mentioning that during your soldering process, you should always try tugging on the wires to make sure that you have a secure connection to the board. It's no fun having a solder joint that comes out right in the middle of testing. After testing the two wires of the main section, I
I did the DC wires. I cut them off, stripped them, twisted the ends, put them into the board, and soldered them down to the board. Basically the same process as with the AC portion. Next, I started securing down some of the passive components. Here I am soldering down a capacitor. Now, here's a very good tip. When you're soldering down components in the dip form factor, it always makes life easier if you bend the leads on the bottom of the PCB. That way, the component stays steady while you solder, instead of having to hold the component while you solder. After soldering, I cut the excess leads off of the capacitor. After soldering in that capacitor, I turned my attention to all the resistors. The resistors are basically the same process as the capacitors, with one extra step. Now, that one extra step is that you have to bend the leads so that it's easier to put the resistor onto the board. I take a small pair of pliers and bend the leads 90 degrees. That way, it fits in the board much simpler. Next, I turn my attention to the voltage regulator. It requires a heatsink, so I secured that down with one screw. After that, I slid the voltage regulator into the holes, and then I secured it with the last screw. Another important tip is to always have a multimeter by your side while soldering. Using its continuity function, you can test for unwanted connections. If there is an unwanted connection when you test across 2 points, it will beep. If it beeps, you can run your soldering iron through the unwanted connection and it will separate it.
Alright, and the final 2 pins to snip off the PCB. Just like so. And I believe we are finished. So, time to test it out. Time for the acid test. Now, you dudes all know what that is. The first power-up of the system. So, I guess, no time like the present. Please don't blow up. Aha! No explosions. Okay, that's good. Let's see. We have got no voltage. We should have AC voltage though. Oh, here. I need to set it to volts AC. We got around 9.9 volts on the AC output. And let me go and grab 2 alligator clips. Alright, so AC portion works. Now as you can see there, right here and right here, I have 2 alligator leads hooked up. I'll bring the multimeter in. There we go. So now maybe you can see, let's maybe put it that way. Can you see there? Yeah. So in theory, if I say flip the switch, and then I adjust this, nothing. No wonder I'm not seeing anything. Here, let's hook these up. And we're off. Okay. So if I hook the ends up now, I'm a complete idiot. There we go. And now 2.2, 2.3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 volts. Oh my. Awesomeness. Okay, and in theory, so this should have a maximum of 25 milliamps, and this should have a maximum of 25 milliamps, and this should have a maximum of well, actually, sorry, this will have a maximum of this will have a maximum of 250, and this will have a maximum of 500 milliamps. So, yeah, fairly successful test. Let's bring it inside. Alright, so we now know this thing right here works without failure. So, how does it work? Well, it works like this. First, you take your poking bit and you stick it into the poking bit receptacle. Then what happens is the power from the receptacle will flow out from one side of the receptacle into one side of the transformer. This is for the DC side, the yellow, blue, and yellow wires. And then this will power the DC side. Then it will flow over into the AC side, and then comes back into the receptacle. Now, there's always going to be a current flowing here. That is why some people will say, don't leave things plugged in, because they're wasting energy, basically. That's sort of true, but it's just a very tiny little bit. So, I mean, I'm sure it won't matter really, but, you know, if you leave it plugged in for like a week, you wasted maybe like at least a watt of power. So, for the DC side, and in fact for both of these sides, what happens is, the AC flowing through this coil creates basically a magnet. Now, in opposition to permanent magnets, this is actually a variable magnet, if you want to think of it that way. Essentially, what happens is the magnetic field will get stronger and weaker, and it'll become. It basically goes strong, weak here, and strong in the other direction. And what that does is it makes this coil right here see a voltage, and in turn sends power to this circuit. Now this will most likely be 15 to maybe 18 volts. And as a matter of fact, if I look in the book, yes, what looks to be 18 volts. Between this one and this one, you'll see both 18 volts. So, then what we do is we go send it through a switch. This switch turns on and off the DC portion. That's this sucker right here. And it flows through two diodes. Now, diodes are basically like, if you think about it in hydraulic systems, it is like a one-way check valve. It only allows water to flow in one direction. Likewise, diodes only allow electricity to flow in one direction, not the other. And that's indicated by the arrow. So basically what will happen is the voltage is going back and forth here. It'll just be going forward, 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 and it'll be like a bumpy waveform. Now if you look well, I'll draw a picture of it actually. It'll just look like this. It'll have a bunch of bumps. Because basically what's happened is, between these two diodes, they've taken one waveform and let it through because it's positive. But with the other waveform, this half, they've taken it and flipped it right side up, like so. Then what we do is we send it through a capacitor. That's this sucker right here, and that's this big mamma jamma right here. Then what we do is we send it through a voltage divider, and that's the potentiometer to tell the voltage regulator how much voltage it should send out to the outputs. Now, at the outputs, we have a smoothing capacitor and a resistor, just to make sure that the power coming out from the voltage regulator is nice and smooth, and then it goes out to whatever you're powering. For the AC side, it's pretty simple. We just send it outward, and it goes from the transformer to two other wires, which are basically constantly powered at 8.5 volts, or in this case 9.9 volts, as I read on the multimeter. And it's a fairly simple operation. In addition, there is it is thoroughly explained in the manual, but if you also want to go more in depth, on YouTube, look up how AC to DC converters work, and you should find some more details about how this works. But that's basically it. And in that case, I hope you dudes enjoyed the video. Subscribe if you're new, and I'll see you dudes in the next episode.